Hello students, here a little video on the Unit 8 test. Some of you have been bemoaning the lack of Cognitive, so the very least I can do is create another video for you guys, and I might even tell you a joke at the end if I actually remember that. So I won't be looking at all of the problems, just some of the ones. So for example, the first one on binomial theorem is just a straightforward application, no need to look at that. You can see how to do that one easily from the marking scheme in case you need to. Let's have a look. The second one is pretty trivial too. No, nothing exciting there, and the area enclosed, we'll see how to do that in another question. So do keep in mind that this is a GDC question. So for example, in question number 3, by golly, these are certainly not easy functions, right? X e to the x. So we are going to find the intersection points, which we're definitely going to do with our GDC. So let's have a look at our GDC. Let's graph these. I think graphing is the way to go. E to the minus x. And then we got minus 3. Don't forget the difference between the minus and the subtractions x, and I believe there was a plus 1. Let's have a look. Well, that's still on radian or degrees, so I better change that. Let's do minus 2 to 2. Something tells me that a small window for these functions, the exponential decaying functions, are pretty powerful. So there's the first one. And there is the second one. I like my window a little bigger. Let's do it to 3. Let's see if we capture everything. Oh yeah, that looks like this is going to work. So I want to find the intersection points. Second calc, number 5. First curve, yes. Second curve, yes. Guess. Boom, first one. So 0.357. So P is less than Q, so basically I would write this as G is X. Therefore, what this leads to, P is 0.357, and let's find Q. Second calc. Yes, let's move to the other one, so it finds the second one. Alright, let's go. And 2.15, and Q is 2.15, and I'm going to do by GDC, so it's clear that I'm going to get all the numerical points if that is going to be necessary. Alright, so by GDC, Pebrew hence find the region enclosed by that. Well, this is gorgeous because I can see that the blue one is all the way above the red one. So all I need to do is find, so let this be the area, this is called it A, is going to be from P to Q of F minus G. That's correct. F of x minus G of x dx, which is going to be, let's just put it in our calculator, math number 9. Let's clear out of this first. Math number 9, f and int, so there was 0.3574, just to one extra decimal place. 2.15. Let's also put 4 decimal places there. Since we already calculated, or since we already input those y variables, I can actually call them up vars, y vars, and I'm gonna do y1 minus vars, y vars, and y2, and let's do it with respect to x. And what do I get? 0.538 to 3 sig figs. Did he say 3 sig figs? He did say 3 sig figs. 0.538 by GDC. Alright, good. Alright, fine. That was that one. Let's have a look at this one. Oh yeah, volume of revolution. Let's first find the x-intercept, so find that one. So when a sine of something equal to 0, well, x equals 0, but that's not going to happen there. So e to the x is equal to pi is another solution, therefore x is equal to ln pi, which I guess if you do it with your calculator is give or take 1.14. Yes, okay, good. So then we're going to find the region enclosed by rotating. Let's have a look. The volume is equal to pi. I need to go from 0 to my intercept, which was ln pi. Might as well do it exact. And then I need to take the function sine e to the x, and I need to square that thing. Now, do I want to do this by hand? I do not think so. I see trig identities and then no help whatsoever. Substitution won't help either. But of course, I can use my GDC. So let's use our GDC. Right, f and int from 0. Oh, you know what I've got? See, I'm in degrees, I knew that. Alright, so let's have a 0 to ln of pi. What am I going to do? So I need some brackets because I need some square sine of what? Of e to the x. And let me see, brackets, square. And with respect to x, so let my calculator do all that job. Now of course need to multiply that by pi, so let's do that, and I get 2.50. So this is going to be 2.50 again by GDC. Right, remember it's a paper 2, so don't do ugly integrals unless you absolutely have to. In this case we certainly didn't. Alright, we need to integrate e to the x squared minus 1 dx. It's a product, so this is a complication. However, it is of the glorious substitution technique form. Why? Because the derivative of the argument of e is give or take, that it means up to a constant, the function that is multiplying it. So u equals x squared minus 1. Therefore, the u by the x equals to 2x, which implies that the x, which is what I need to substitute away, is 1 over 2x du. So I can write that as x e to the u 1 over 2x du. X's cancel out, glory, the half comes out in front, the derivative of e to the u with respect to u is e to the u. So this becomes u plus c. Now please substitute it back. E to the x squared minus 1 times a half plus c is our answer. Alright, let's see, how does it help us with 5b? It says if I have a derivative function f primed is equal to the one that we had integrated over here, find f of x. Well, that's easy. F of x is going to be the integral of what we just did. Of course, there is this c there, but I know that f of minus 1 must be 3. So a half e to the minus 1 squared is 1, minus 1 is 0, e to the 0 plus c, e to the 0 is 1. Therefore, c is equal to 3 minus a half, which is 2.5. Therefore, the function f of x that I'm interested in is a half e to the x squared minus 1 plus 2 halves. Bueno. Good. Question 6. We're cruising here. Whoa, this is ugly. A velocity is given by 7 cos t minus 5t to the power of cos t for the first 7 seconds. Find the initial value. That means when t is equal to 0. Well, cosine of 0 is 1, so 7, and 0 to the 1, well, that's also, so it is 7 meters per second. Find the maximum speed. So the maximum speed doesn't care about signs. So the maximum speed is the furthest this graph gets away from v0, which seems to be there. In other words, I'm looking for, so the max speed looks to be the second minimum. Now look at that ugly function. How am I going to do that? Of course, by GDC. Alright, so where's our GDC? Okay, let's go back to y. I don't need that. I don't need that. So 7 cosine x, and of course my mode is already in radians, so I don't have to worry about minus 5 times x to the power of, that's where my cosine comes, cosine of x. Alright, good. Now I need to go from at least till 7, right? So let's go till 9. I can see a little bit more. It looks like I go at least from to plus 7. And the other one seems to be a lot lower. I don't know. Let's do minus 35, whatever. Let's do that to 10. All right. So there is the graph, which seems to coincide quite nice with what we have. All right, find. So I want to find a second minimum, so I want to find the value over there. Second calc. I want to find a minimum. I want to give the left bound, so the left hand to the left of the minimum. There, to the right of the minimum. There, and a guess in between. Minus 24.7, but of course I don't care about the sign. The max speed is 24.7 meters. Yeah, the units are meters per second. All right, good. Write down, so this should be fairly trivial, no calculations. The number of times acceleration of p0. So the acceleration is the derivative of v. When this is 0, that means that the derivative is 0. So I'm looking at the stationary points. Right, so let's have a look. I've got a stationary point there, I've got a stationary point there, and a stationary point there. All right, 3. Boom, 3 points in the back. That was simple. Find the acceleration when p changes direction. All right, change direction. Change direction is the same as crossing, or let's say the v of t crossing the t-axis. Right, so which is there. So I need to find the acceleration. So to find the acceleration, I first need to find the time. All right, well, I still have the function, so I'm looking for the value over there. Second calc, find the 0. Need to go to the left of the 0. So let's move my cursor all the way to the left of the horizontal axis intercept. Come on, move, move, move. And then to the right, move, move, move. And then to the left. And then, oh, sorry, to a guess, 0.8639. Okay, so this happens at t equals 0.8639. Let's put another, I think it was 85, right? 0.86385, 0.86385. Okay, good. So now the acceleration, find the acceleration. So I need to find the acceleration at this point, which is nothing more than differentiating the function. Let's call this point TP, and evaluating that. But since it is a GDC, I might as well just do it. So I put it into y1, so I can go to math, f and deriv. Oh, why did I always forget to get out of here? Math, and derive. So I'm gonna respect to that, I'm gonna use the y-vars function y1, and where 0.8, what was it, 8.66385. Please calculate it. Minus 9 in acceleration is a vector, so I care very much about a minus sign. Minus 9.25 equals minus 9.25 by GDC. Except this was also by GDC. Nice 4 marks. So, the IB doesn't care about units, but golly, I do care about units. So there is that. Okay, find the total distance traveled. Find the total distance traveled by this thing. All right, so the distance traveled is the integral, in this case, first 7 seconds. Distance is the absolute, so I need to put this in absolute signs. dt. All right, well, this is a GDC question, so why would I not use my GDC? All right, math, f and int. All right, from 0 to 7. I need to put the absolute sign, so I'm gonna do that. Math, number, absolute, and I'm gonna put y1 in there. No need to type it again. All right, done that. And I'm gonna integrate with respect to x. And please calculate. Ooh, look at this. It's a lot of work. There you go. 0.6 or 63.9. 63.9 meters by GDC. Distance, of course, is the total meters moved, and that's why I put it in absolute value signs. What it does, whatever, if you go back at this, what does the absolute value sign do? It makes this look like this, right? So this is absolute value, and this is exactly what we want. Good. That was an interesting question. 7 is 7 an interesting question? Oh, why not? Okay, P is at rest when t is 1. Okay, there. So this is a VT graph, and there. So it's this function until 1 second, and that function afterwards. So I need to find a value when this thing is 0. Gee, is this a GDC question? I believe it is. So let's have a look. Right. Okay, so let's clear this out. Okay, so got 3 square root of t, or in this case just x, plus 4 divided by x squared minus 7. All right, let's the window goes to 12, so let me change my window as well. 12, I have no idea how high it goes. Minus 20 to 20. Okay, good. So that's the first one, that's 1 second, and there's a second one, so let's find it. Second calc. Please find the 0, left of it, enter, right of it. Enter, and guess in between, and there 5.222. Yes, 3 sig figs. All right, so this plus 4 over t squared minus 7 is 0. Gives me t equals 5.22 seconds by GDC. All right, what do I need to do with this? Find when t is q, the acceleration of p is 0. Find the value of q. Well, acceleration is 0. That means the derivative of v is 0, so over there. Okay, so basically find the stationary point. This is paper 2. So let's find it over there. I'm going to change my window a little bit so I actually see what's going on. Let's go. This looks to be sufficient. Yes. Alright, let's find that. Okay, second calc. Minimum. Go to the left. And go to the right. A guess in between. And the minimum is 1.9, so it happens at 1.95 seconds, and it is actually I don't care about that. So at stationary point, and that Q is equal to 1.95 seconds. All right, hence find the speed of P when that is true. Well, that's easy. Just found it. It is, the velocity is minus 1.56, so the speed is 1.76 centimeters, right? So by GDC is simply the value of the velocity there, but stripping any sign, any direction information. Find the total distance traveled between T1 and T2. So find it, no, T1 and TP, T1 and TP, which was here, right? So find that area. So what are you asking? Find the distance traveled between, yeah, they do. Okay, so it's the second part, so from 1 to 5 point, I can't remember what was it, 5.1 to a few more decimal places, right? 5.218 or something like this, and I want to do that 3 squared of t plus 4 over t squared minus 7. The distance, I might as well put it in absolute value signs. Let's use a calculator for that. Let's get out of it. Math 9 from 1 to 5.218 of variables, y variables, y1 respect to x, and this minus that, so distance doesn't care about that, so I must take the absolute value. I didn't do absolute value sign. I know it's all below, so I know I'm going to get no cancellations. So this is 4.45 centimeters, I believe. The units are. Alright, hence or otherwise. Find the displacement of P from A to that. So I need to find, okay, so the displacement has to take into consideration, okay, good, so I see that. So the displacement, I've got two functions from 0 to 1, minus 2t plus 2 dt, and I'm not going to strip out any, I want to have the net area, so I'm going to leave everything in. So I already know what this is, so this was minus 4.45 because this is what that was. Again, you can use a GDC for this. This happens to be 1. So it is 1 minus that, 4.45, which is minus 3.45 centimeters is the displacement. So that's how many centimeters I'm away from where I started. Alright, that was that. That was the Unit 8 test. Alright, so there's a fine line between a numerator and the denominator, but only a fraction of the people find it funny. Alright, see you later. Bye bye.